Hey there! Welcome to your new lesson. 2.6 Surface area of composite objects. Remember to write down your name. Mine's Tara. You don't write that though. That's not your name. And make sure that you put the date down. Okay, so let's talk about what even a composite object is. So the definition of a composite object is a 3D object, three-dimensional object. That is made up of more than one 3D shape. So if I were to give you this object right here, I would be able to say determine the surface area of the object. So what we're going to do first is, so step number 1, find surface area of individual shapes to find 2 times the overlap. And we'll talk about what that is. And then 3, we're going to say 1 minus 2 equals the total surface area. Okay, so we're going to break it into the individual shapes. So here I see a triangular prism over top of a rectangular prism. So just a few things to remember. The area of a triangle is half base times height, and the area of a rectangle is length times width. We also have the formula for a rectangular prism too. So if I were to break this one up, I would say that this bottom one right here is 6 centimeters. I'm just copying from up here. This guy right here is going to be 9 centimeters, and this guy right here is going to be 5 centimeters. So if I say that this is my length, and this is my width, and this is my height, I can just plunk that into the formula. So surface area of a rectangular prism is 2 width length plus 2 length height plus 2 height width. So I'm gonna, instead of writing L for in the formula, I'm gonna make sure that I put in 6. Instead of writing W, I'm gonna make sure that I write in 9. And instead of writing an H, I'm going to make sure that I write 5. So 2 times width, which is 9, times length, which is 6, plus 2 times length, which is 6, times height, which is 5, plus 2 times height, which is 5, times width, which is 9. 2 times 9 times 6 is 180, plus 2 times 6 times 5 is 60, plus 2 times 5 times 9 is going to be 90, for a total of 258 centimeters squared. So this is for my shape 1. So I'm just going to put 1 here, and so this is for shape 1. Now what we need to do is we need to find the surface area of that triangular prism. So for the surface of the triangular prism, make sure that we pay attention to the dimensions here. So each side of the prism is a right angle, okay, that's helpful, with a base of 6 and a height of 5. Now we know that this length right here is going to be our 9, and we know that this length right here is going to be our 8. So I'm going to draw the shapes. So I have my triangular prism here, okay, and I know that, triangle, and I know that I have times 2 of these. Okay, I have this rectangle, that looks like that. And I just have one of those. Now I have the back, and we're going to put in the dimensions in just a little bit. Okay, so I have one of these. So this is the back that you can't see right here, but it's right there. And now the bottom. So I'm trying to draw them all kind of in perspective a little bit so that it kind of helps you match them. I only have one of these. So now let's go through and put the proper dimensions on. So if this right here is the triangle, I know that this is going to be 6. And I know that this is going to be 5. I don't need to have my hypotenuse for the dimensions of, or to find my area of the triangle, so I don't have to write that in. So this one right here, this is going to be 8 by 9. Okay. This one right here is going to be 5 by 9. And this bottom is going to be 6 by 9. So now let's find the area here. So area of this one is going to be 1/2 times the base times the height times 2, because we have 2 of them. So that's going to be 30 centimeters squared. So now this shape right here, I'm just going to write in the shape here. The area is length times width, so 9 times 8. So that's going to be 72 centimeters squared. This area, I'm going to write it in here, but I'm going to just change this a little bit, so times 1. So the area is 5 times 9, which is going to be 45 centimeters squared. And the area of this one, since it's a rectangle, just like the other two up here, 9 times 6, which is going to be 54 centimeters squared. So now what we need to say, total surface area for the triangular prism. That's just my little drawing for that. Okay, that's going to be 30 plus, so I'm just going to check mark that, 72, yep, plus 45 plus 54. So then my total surface area here is going to be, 201 centimeters squared. So what we want to do is we want to add the two surface areas and then subtract twice the area of the overlap. Let's create just a little bit of space here, so area of overlap. So we got to take this into in each context. So if we're looking at this overlap here, if I were to draw this shape like this, the shape where the two shapes touch each other, this is going to be a rectangle. Sometimes it's going to be a circle. Sometimes it's going to be a triangle. Sometimes it's going to be a rectangle. But this is a rectangle here. So when I talk about the overlap, I say take this whole entire shape, dip it in paint, and rip the two shapes apart. You're going to see an unpainted piece on the bottom of the triangular prism and on top of the rectangular prism. That's why we need to subtract 2 times that, because we've taken into consideration the bottom of the, we've taken into consideration the top of this one, and we've taken into consideration the bottom of this one. We've added that, so we need to subtract that off. So the shape of the overlap is actually going to be this 9 by 6. So I'm going to say area of the overlap times 2. It's going to be 9 times 6 times 2. So that is going to be 108 centimeters squared. So the last step here is add the two surface areas and then subtract twice the area of the overlap. Okay, so the surface area for the first shape is 258. So surface area is 258 plus the area of the triangular prism is going to be 201. See what I did there? 201. And then I'm going to minus 2 times the overlap. Now we've calculated 2 times the overlap already, so I'm just going to subtract that 108. So then I get a total area So that's going to be 351 centimeters squared. That's my final answer. Let's look at an example that takes into consideration or that uses cylinders. Now, this is a cylinder on top of a cylinder. So truly, we can throw basically like any combination of things at you. So something to keep in mind here, though, the shape of this overlap is going to be this small circle. Okay, but remember, we can always find the area of a circle, and that's just pi r squared. The area of a side of a cylinder, that's just this part here that goes all the way around. That's what this is. But if you want to remember the area of the cylinder, its surface area equals 2 pi r squared plus 2 pi r h. So this is the side, and these are the two circles. So I'm going to give, it says just find the surface area of the composite object, so I'm going to call this cylinder number 1, this is cylinder number 2. Okay, so I'm going to find the surface area of cylinder number 1. Now, just because, you know, math teachers like to be really tricky, look what I've given you here. I've given you the diameter, not the radius. We know that the radius of this one is going to be 2. And while I'm at it, I might as well do this radius here too so I don't forget. Because when we're in the thick of things, sometimes we forget. So this is going to be 6 centimeters. So I'm going to find the surface area of this first one. It's going to be, and like a good little mathematician, I'm just going to fully just write out my formula. If you write the 2 pi r h before the 2 pi r squared, that's totally fine. That's just how my brain worked right at this moment. So 2 pi, and I'm going to be just working on this first one, so I know that my radius is 2 squared plus 2 pi 2 times, and the height here is going to be 14. So this is going to be 25.13 plus this guy right here is 175.93, and altogether I get 201.06 centimeters squared. Now I did that very fast. My suggestion to you folks is make sure that you know how to punch this into your calculator, and make sure that you're practicing on a calculator that you will be using for assessments. So let's look at surface area of the second cylinder. So the surface area of this one, like a good little math student, 2 pi r squared plus 2 pi r h. The radius for the bottom one is 6 and the height is 4. So I'm going to say 2 pi, and then r is going to be 6 squared plus 2 pi 6 times 4. So that one is going to, if you add it all together, it's going to be 376.99 centimeters squared. So now the third step is I need to make sure that I find the overlap. And I multiply it times 2. So I look at the overlap, and the radius of that overlap is going to be 2. So when I look at the area of a circle, it's going to be pi r squared. But I need to multiply that by 2. So in this case, the radius is going to be 2. So when I do that, it's going to be 25.14 centimeters squared. So the total surface area is going to be 201 plus 376.99 minus 2 times the overlap, which is 25.14. So that final answer will be 552.85 centimeters squared. Fabulous. So let's talk about the summary. You're going to practice using a worksheet. So come and find that at the front. But before you work on that, let's talk about the summary. So first things first. So you're going to find surface area of individual shapes. And then you're going to find 2 times the overlap, And then I find when I go, if I call this A shape and B shape, I'm going to say A plus B minus the answer that we find in 2. That's going to be our total surface area.